Dear students, this video finds you, your family members and friends are doing well and staying safe and healthy. Greetings from Department of Mechanical Engineering, St. Joseph Institute of Technology, OMR, Chennai. So, we are happy to inform you that we have started a YouTube series for the tough subjects. So, in this regards, I would like to present my YouTube video on finite element analysis, Unit 2, Introduction to One-Dimensional Problems. You will be having a series of YouTube lecture which you can follow, and you can post your comments and questions, feedbacks in the comment section, which will give us an opportunity and chance to improve our future and upcoming videos. So before starting into the unit number 2, which is one-dimensional problems, I would like to touch upon on few basics which would make it for you easy to follow my lecture series. So what is FEA? So FEA, it is a numerical method for solving problems of engineering and mathematical physics. In this method, a body or a structure in which the analysis to be carried out is divided into small elements of finite dimensions called finite element. Then the body is considered as an assemblage of these elements connected at a finite number of joints called nodes or nodal points. In very simple, so finite element analysis is a method instead of solving the whole problem or a problem of an entire body, we formulate equation for each finite element and then we combine together to obtain the solution of the whole body. So in this problem, you can see a structure is divided into finite number of elements in which we will find out the solution for each element, and then we will assemble the solution of each individual element in a particular form and with particular condition to obtain a final solution. So as you would have been seen about this governing equation on the boundary condition on your unit number 1, I would just like to touch upon what is this. So a governing equation. So in this governing equation, so we would have seen various governing equation which will be defined on the basis of various physical problems and boundary condition, and it also boundary condition depends upon the application, and there are lots of boundary condition depending upon your structure. You have boundary condition depending on your structure, loading condition, temperature condition, and etc. So these are the various field where we will apply our finite element analysis techniques, which has elastic problems, thermal problems, fluid flow, and electrostatic problems. So this slides give you a fundamental concept of you would have remembered this equation, finite element equation, general finite element equation, which is F equal to K into U, where F is your force matrix, K is your stiffness matrix, and U is your displacement matrix. In generally, we will call it as F is an action, U is an behavior, and K it is an property. So this K matrix differs for various field of problems. You can see in this, for elastic problem, you will call it K will be a stiffness matrix, which will be majorly using on your Anna University syllabus. So mostly we will be carrying out with this first row of problems: stiffness, displacement, and force. This we would have become come. So when thermal problem, K will be related to conductivity and U will be your temperature, and whereas your action will be of an heat source. In fluid problems, where property matrix K would be related to viscosity, and your behavior matrix which would be related to your velocity, and your action would be related to the body force. The same it goes for the electrostatic. So as for our syllabus is considered, you just remember this first row. This is what we gonna do. So now let us come to the unit number 2. I start unit number 2 with a confirmation, with a knowledge that you have already have done with unit number 1. You have a thorough and basic knowledge of unit number 1, so that you can understand all the basic concepts in this. So one dimensional problem. In one dimensional problem, it is we have a very first term, it is bar and beam. So bar and beam elements are considered as an one dimensional element, which we often use to model any frame structures, trusses, or whatever it is. We will use either a bar or a beam element to formulate. So what is bar? So bar, it is a member which resists only axial load. Or what about beam? Beam, it can resist axial, lateral, and twisting load. So whereas truss, it is an assemblage, it is just an assembling of bars or beams with a pin joints in a framework. So you can see this image, and this a bar which is resisting an axial load, and this is an example for a beam which is resisting for an transverse load. So henceforth in various problems, when you go for an actual practical conditions, you will come across these terms many times. So what's the basic difference? What is rods, bar, beam, shaft? Moreover, in a physical element, everything seems to be a single same picture. So then what really is the difference between these four: bar, beams, rod, and shaft? So moreover, rods and bars are the same member which are subjected to an axial load. It may be either a tensile load or compressive load. What's the difference? The difference is in physical structure. So when the cross section of your member is a circular one, then we will call it as rod. And any other structure other than circular, so we can mention it as non-circular cross section, we can call it as bar. So what does mean? Beams, as usually we discuss it as a transverse along with axial. It may be have an axial load, but a beam structure will resist a transverse. And what is shaft then? So shafts, it is a member which resists torsional load in addition to axial and transverse. Along with axial and transverse, if it resists the torsional load, then we will call it that member as shaft. So shaft, it can be either circular or non-circular. Now we will come to the basics of some problems. Before getting into the problems, I just would like to touch upon few basics which I would like to recall those basics before getting into the problem. So this actually you would have seen in unit number 1, finite element procedure of finite element analysis, in which we have an first step. It is dividing a structure into finite elements, discretization. So that is what I have given here. So in this you can see a bar which has been divided into 5 elements. You can see these white dotted ones, that we call it as node, and number encircled we will call it as element. So this is element numbering and this is node numbering. So this is how you divide your member into a very small number of finite divisions. So there are lots of conditions that you would have please recall and recollect the procedure of finite element analysis in unit number 1, because there are various conditions in which we have to do this discretization process. So this is another step. It is a cantilever stepped bar, where again I have 4 different elements. So 1 2 3 4, this is element number, and we have 1 2 3 4 and 5 node numbers. And before getting into the problem, I would like to touch upon various types of loading. So body force. So body force, it is a force distributed acting on every element volume of the body. Body force. Traction force is nothing but a distributed force acting on the surface of the body. So point load is an force acting at any particular point which causes the displacement. I just want to touch it upon. I just want to touch it on the few basics which is very much required for your problem point of view, and this video will be an introduction before the starting of your problems. So I would like to touch upon the final one of stiffness matrix. So what does really stiffness matrix is? Stiffness matrix is the art of, it's a very important thing which decides your approximity of your solution. The solution will be so as you know, finite element analysis is an approximate solution. Your approximate level depends upon how confinedly you assemble your finite and evaluate and process your stiffness matrix. So what is really stiffness matrix is? So to be in a simple word, what is stiffness? What does the word stiffness mean? You just forgot FEA. Now you just what the stiffness means. So stiffness is the amount of force required to cause and displacement. It is a resistance to the displacement, which is called stiffness. The same concept is valid for stiffness matrix also. If you think of a structure which has multi degrees of freedom, then you will have many stiffness term associated with this degree of freedom. In finite element analysis, these are written in a matrix form, which is called as stiffness matrix. So upon evaluating or assembling a stiffness matrix, as we have already discussed, so this matrix, it is an symmetric matrix. It will be an symmetrics. And next one, the sum of the elements in any column must be 0, and it is an unstable matrix. If you find a determinant for this matrix, then it will be 0. And your dimension of a stiffness matrix will be depending upon your number of nodes. For example, if you take this one, if you apply the FEA procedure as per our FEA concept, on upon assembling, you will get a 6 cross 6 matrix. You will have 6 rows and 6 column. Why? Because it have 6 node, so you have 6 number of node, so hence your final stiffness matrix will be 6 cross 6. So this is a few basics which I would like to touch upon, so that when we go for the coming video on the problems, I would like to concentrate more on problems. As you know, enough discussion of the basics is already done in the classroom. I wanted to solve more problems, university problems. I'm planning to take many university problems and then we will solve it. So thanks for watching, and since this being my first video, I would like to have your feedback in comment section, so that based on your comment I can optimize my upcoming videos. So as you know, it's really difficult to make PPT for FA, since as you know, in classes you would have find difficult to write in a notebook for to solve a problem. You'll ask me like, so this problems runs for 4 or 5 pages. In these cases, preparing an PPT for FE is really tedious, but it is not impossible. So we are trying our best. So I would like to have some feedback from you guys, so that we can optimize it further. Okay, thank you for watching. Please keep learning, stay safe at home. Thank you.